Okay, so the irrational conjugates theorem just tells us that if you have a solution a plus the square root of b, then the conjugate of that, and hopefully you remember what conjugate means, the conjugate of that, changing this middle sign, is also a solution or a zero. So if you're given this one, then automatically you know this one is also. And that will come in handy for our next problem that we're going to do. I think that's number 13. Okay, so now we're going to solve this problem using the not complex conjugates, that is a theorem also, the irrational conjugates theorem. Right now I know two solutions, but if you think about what we just talked about with the irrational conjugates theorem, then we actually know three solutions. Negative 5 is a solution. 4 plus the square root of 2 is a solution. That's an irrational number. So then if 4 plus the square root of 2 is a solution, so is its conjugate, 4 minus the square root of 2. So what we're going to do, we're going to work backwards. Right now we know that when we solve the polynomial that these came from, that x equals negative 5, x equals 4 plus the square root of 2, and x equals 4 minus the square root of 2. Okay, so I am going to go to the next step, which would have been when you put out the zero product property, you put together the zero product property. So I'm going to add 5. X plus 5 equals 0. I'm going to subtract 4 and subtract the square root of 2. And subtract 4 and add the square root of 2. I'm going to go to factored form from here. Which is what we would do if we were solving. We would factor our polynomial and then we would do the zero product property. So again, we're working backwards. Okay, now I'm going to distribute. I'm going to distribute x times x. X times negative 4. X times negative square root of 2. Then I'm going to distribute 5. 5 times x. 5 times negative 4. 5 times negative square root of 2. I'm going to combine what I can. That will keep it as simple as I can, even if I have to distribute a little extra. Okay, there's nothing to go with x squared, so I'll bring that down. Negative 4x and positive 5x gives me positive x. And then I really do have like terms here, but it'll be much simpler if we just leave them like they are. The only other thing I have is the minus 20. So I'm going to go ahead and put minus 20 here, and then put these two after it. Then I'm going to bring down that next polynomial, and I'm going to distribute. Okay, so x squared times x is x cubed. X squared times negative 4, negative 4x squared. I'm doing this, I'm distributing x squared times x squared times negative 4, x squared times square root of 2. Okay. Plus x squared square root of 2. Now I'm going to distribute my x. X times x times negative 4, x times square root of 2. Okay, so plus x squared, x times negative 4, negative 4x, x times square root of 2, plus x square root of 2. Okay, now I'm going to distribute my negative 20. Negative 20 times x, negative 20 times negative 4, negative 20 times square root of 2. Negative 20 times negative 4, is positive 80. Negative 20 times square root of 2, negative 20 square root of 2. Okay, and as you can tell, I'm going to run out of room, but that'll be okay. I'll just put it underneath there. Okay, now I'm going to distribute this. Negative x square root of 2 times x. This times that. Okay, so that would be negative x squared square root of 2. And then positive 4x square root of 2. And then negative 2x. Let me explain that really quick. Sorry for the sloppy negative. Square root of 2 times the square root of 2 is 2. A negative times a positive is a negative, and so this would be minus 2x. Okay, and then I'm going to distribute the minus 5 square root of 2, so that's going to be minus 5x square root of 2 plus 20 square root of 2. Negative 5 square root of 2 times negative 4 is positive 20 square root of 2. Negative 5 square root of 2 times positive square root of 2 is a negative 5 times 2, which is 10. Okay, now I got to combine all these like terms. Okay, so I want to do some marking if I can. Never mind, I'm just going to start from the beginning and combine. I think that's much faster. Nothing to go with x cubed, I don't think. Okay, what can go with negative 4x squared? That's it. So negative 4x squared and positive x squared is negative 3x squared. Okay, let's do next. What can go with x squared square root of 2? Is there another x squared square root of 2? Oh, look. X squared square root of 2 and negative x squared square root of 2 cancels out. Okay, good. Next, I've got minus 4x minus 20x minus 2x. Minus 4x minus 20x minus 2x minus 26x. Okay, next is x square root of 2. 4x square root of 2 negative 5x square root of 2. So 1x square root of 2 plus 4x square root of 2 is 5x square root of 2. So I got those combined. And positive 5x square root of 2 and negative 5x square root of 2 goes away. So that cancels out. Okay, what's next? 80. Okay. Anything, let me just do this. Positive 80. Positive 80 and negative 10 is positive 70. And we're almost there. Okay, so I have negative 20 square root of 2 and positive 20 square root of 2, and that gives me 0. So I am, see the finish line. It is in sight. Okay, so this equals 0, and then to write a polynomial function, whatever function notation you want to use, would be x cubed minus 3x squared minus 26x plus 70. We just worked backwards. I know that was quite a challenge, but we rose to the challenge and we combined all those terms that were like, and we got our polynomial function. Okay, on to the last example. Okay, it says use the information in the graph to answer the questions. Hopefully, when you look at this, you know this is a cubic function. It is in that shape of that family of functions that we talked about at the beginning of the year. Also, we know it's odd degree because the ends point in opposite directions. We know the leading coefficient is positive because this right side points up. We know the solutions. Negative, what is it? Negative 6 and 0. We also know that one of those is a double root. Can you think which one is a double root? Is it -6 where it crosses through, or 0 where it touches? And hopefully you knew it was 0 where it touches. So that means 0 occurs twice, and I need that here. Not necessarily in the answer to letter A, but when I write this cubic function, I need that fact. Notice there aren't any irrational solutions because all 3 of my solutions cross or touch the x-axis. So this is going to be much easier than number 13. Okay, we're going to work backwards like we did with number 13. Right now I know x equals -6, x equals 0, and x equals 0. And forgive me for this next step. Some people need to see this. We can scratch it once I write it, but I just want to show you. So if I were doing the solutions, I would move this over. X plus 6 equals 0. X minus 0 equals 0. You do not have to do this. Hopefully you realize it's just x. And then go to factored form. And I think I'm just going to erase that and go to factored form just because it's so much easier. When we have that x equals 0, we know that x is one of the factors in the polynomial. So that means I have x plus 6 times x times x. And I could say I have x plus 6 times x squared. I could also use the commutative property of multiplication and switch those around. And then distribute. Oops, x squared times x is x cubed. X squared times 6 is 6x squared. Now it says write an equation of the cubic function. So this is an equation, but I'm going to go ahead and put the cubic function f of x equals x cubed plus 6x squared. That would be the answer to letter B.